Okay, this is graph sheet number 1 that I gave you the first day we started displacement versus time graphs. We already went over the back side, but we haven't gone over we already went over the front side, but not the back side, the velocity versus time. For some of you, we started it, but I'm going to start it over again just for the people that weren't in class, or the people, okay? So it's velocity versus time, and the first question is, I moved it up so we could see the whole thing, sorry. First question is, what is the object's maximum velocity? So to get the velocity in a velocity versus time graph, you just read it off the side. So when was it maximum? It was maximum when it was going 30 meters per second west and 30 meters per second east. So over here you would write 30 meters per second east and west. If one was bigger than the other, you'd only put the bigger one in, but because they're both the same, you have to put both in. What was the object's velocity at 5 seconds? So you go to the 5-second spot, you go down, you hit the line, you go across, and you see that it's 17.5, and you do kind of have to estimate. 17.5 meters per second, and it's negative, which means it's west. Okay, what is the acceleration at the 5-second point? So again, this is the 5-second point. To find the acceleration on a velocity versus time graph, you have to find the slope. So pick 2 points. So I would pick the endpoints, 7 seconds and 0 meters per second, and 3.5 seconds and minus 30 meters per second. Okay, so then you do the slope. So A is going to equal y2 minus y1, so I would do 0 meters per second minus a minus 30 meters per second. And that's going to get divided by, if you start with the 0, you have to start with the 7 seconds minus 3.5 seconds. So you're going to end up with a minus will be a positive. So 30 meters per second divided by 3.5 seconds. If only I had a calculator to do that. There it is. It's going to be, I think 8 point something. 8.57. So right here, 8.57. It'll be meters per second squared. And it works out in the end to be positive, which means it's east. Okay? And that's true because it's slowing down going west, which means its acceleration will be east. If it was speeding up going west, like over here, the acceleration would be west. But it's slowing down because it's at minus 30, going down to 0. So it's slowing down 30 meters per second to 0. And the negative tells us it's traveling west. So slowing down going west, which means it must be accelerating east. If it's slowing down, the acceleration is always opposite direction of the motion. If it's speeding up, the acceleration is always the same direction of motion. When did it have constant speed? On a velocity versus time graph, it has constant speed everywhere there's a horizontal line. So here, 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 and even here. So what are those times? 2 seconds to 3.5 seconds, 7 to 8.5 seconds, 11 to 11.5 seconds, and 13 seconds to, looks like 14, okay, or maybe 14.5. When did it have negative acceleration? You can interpret this 2 ways. It might mean when did it have negative slope? And if it means that, then it's here from 0 to 2 seconds, and here from 11.5, so 0 to 2 seconds, and 11.5 seconds to 13. That's when it has negative slope, and the slope of the graph is the acceleration. So that's probably what the question meant. It could have meant when was it slowing down, and that would be from 3.5 seconds to 7 seconds, and 11.5 to 13. But here it's not negative acceleration. They probably mean negative acceleration to end up being west in an east-west graph. But if I ask you in a test or an assignment, I'll make it clearer. When did it have negative velocity? Everywhere below the line, below the x-axis, so 0 to 7 seconds. What was the displacement at 3.5 seconds? So to do that, you have to find the area under here. So base times height, 1/2 in the first section. So 1/2 of 2 times 30 will be 30 meters, and that's west. And then this is base times height, 1.5 times 30, 45 meters, and again it works out to be negative, so that's west. So what is the displacement at 3.5 seconds? 75 meters west. Add them together. What distance did it travel in the first 7 seconds? So now you need to do this whole big triangle here too. Ignore that line, it was from earlier. So now the base is 3.5 seconds times 30, and then divide by 2, and you get, again, negative, which means west, 52.5 meters west. Distance traveled, just add them up, so add that 52 to your 75, and you get 127.5 meters. It's distance, so you don't need a direction. When did the object first start to travel east? Right here, right? West, 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 stopped. It begins to travel east at 8.5 seconds when it begins to go above the line. What is its total displacement? So we found this total distance, or displacement, to be 127.5 meters west. That's in the first 7 seconds. So now we need to find this part. So again, find the areas of this first triangle. Base is 8.5 to 11, so that's 2.5 times the height is 30, and then you need to take half of it. So this one will be 37.5 meters, and it's positive, so it's east. This guy is a half base, and its height is 30, so it's going to be 15, right? Base times height. 15 meters, also east. And then this one, half base times height, so 1.5 times 30 is 45. Half of that is 22.5 meters, again positive, so it'll be east, 40, 60. So this whole thing will be 75 meters east. So when they ask for the displacement, it's going to be 127.5 west minus the 75 east. And you end up getting 52.5 meters. Keep the direction of the larger, west. Right? Subtract and keep the direction of the larger. Total distance traveled, though, we're going to add them up, right? Traveled 127 meters west and another 75 meters going east. We don't care about the direction for the distance, just add them together, 202 meters. Average velocity in the first 13 seconds. So remember, average velocity is displacement over time. So VAV equals delta D over time. So the D was 52, sorry. 52.5 meters divided by 13. And when you do that, you get 4.038 meters per second. So down here, 4.038 meters per second. Always the same direction as the displacement, so west. Average speed is going to use this one. So average speed is distance over time. So it's going to be the 202.5 meters over the 13. 202.5 divided by 13. And you get 15.5769 meters per second, no direction. Did it ever return to its starting point? The answer is no, because it went 127.5 meters west. We just found that. And then it stopped, and then it came back 75 meters east. It never actually got back to where it began. So no. In the last one, describe the motion. So it's speeding up going west, constant speed going west, slowing down going west. Stopped, speeding up going east, constant speed east, slowing down going east, stopped. Okay, there it is.